Okay, so here we're going to have a look at 2014, question 3, part A. Now it's a nice little simple question at a glance, but there's a little bit of work in it, and I'll be honest with you, the algebra is dirty. So, first of all, let's lay out what we have in a little diagram. So a particle is projected at speed u, angle 30 degrees. Okay, so we know this so far. It's going to potter along level ground, up and down, and hit the ground. We are interested in the time it is above 7.35 meters. Okay, so there we are, 7.35. And it's 2 points in this one, so the peak is somewhere above that. And we are going to call these T1 and T2. Okay, so that's what we have. Now, let's see how we can begin to lay this one out. So first of all, let's look at stuff in terms of i's and j's. Okay, our different components. So the ux is going to be u cos 30, which is root 3 over 2 u. Okay, and if you don't know these, you're getting used to them after a while. You can stick it into a calculator. Uy is u sine 30, this component here, and that is, of course, u over 2, half u. Now, what else do we know? We know ax equals 0 and ay equals minus g, because we defined going upwards as positive. Okay, so let's see how we can begin to figure this one out. Well, we are interested in the vertical distance. So if we look at sy, okay, just to back up a small bit, the equation we're going to use is, of course, our linear motion equation. S equals ut plus a half at squared. Okay, and you can break this out into position vector. For a question like this, you don't really need to. You can just sort of say sy is uy t minus g over 2. Okay, a is minus g. Let's just tidy this up, t squared. So let's see where we're going to go from this one. Well, we know that is 7.35. So it's time to put some numbers in and take a deep breath. Well, 7.35 equals u over 2 by t minus g over 2 by t squared. Well, the obvious thing here to tidy it, make our life a tiny bit easier, is to multiply by 2. We'll adjust that space there. So 14.7, should go through that one in your head, is ut minus gt squared. Okay, so that isn't going to get a whole lot prettier. Now we have a little bit of decision to make. We're going to get that just positive, make it a small bit prettier. Gt squared. We'll just swap all the signs in one go. Minus ut plus 14.7 equals 0. So, quadratic time. Now, you have two options. You can either leave the g there, so your a is g, and the a and the b and c in the quadratic equation, or you can divide everything by g. Pros and cons to it either way. I'm going to divide it by g, because if I look at 14.7, you'll notice that 14.7, you begin to recognize these numbers after a while, divided by 9.8 is 1.5. So that looks not too horrific. So I'm going to end up with t squared minus u over g t plus 3 over 2 equals 0. Okay. Now, I do have a fraction, and that's the pain and suffering I get for having a simpler number here. Okay, lay them out. A is 1. B is minus u over g. Okay, don't forget the minuses, easy one to do. And c is 3 over 2. So now we're going to go into our equation here. So t is minus b, so is u over g, plus or minus b squared, so let's square this straight away, u squared over g squared, minus 4ac, 1 by 3 over 2, all over 2a, which is 2. Okay, now time to do a bit of housekeeping and tidy this one up. So t is u over g plus or minus square root of u squared over g squared minus 12 over 2, which is 6 over 2. Now, that's as far as I'm going to bring this one, because this will get a small bit easier. The key bit of information they give us in this one is that T2 minus T1 equals 1.5. All right, so that's given to us in the question. My two values of T is going to be u over g minus all of this, which is the smaller one, and u over g plus all of this, which is the bigger one, because T2 is the bigger one. And we've now got to figure out, well, there's a lot of mess here, but we do know if we subtract one from the other, we get 1.5. So let's just go straight to that step and see where this goes. So what we'll find is that we have 1.5 equals T2, which is going to be u over g plus, because it's the bigger one, u squared over g squared minus 6 all over 2, tedious I know, minus u over g minus u squared over g squared minus 6 all over 2. Okay, so again, this section here is T1, and this section here is T2. Okay, plus because it's bigger, minus because it's smaller. Now, let's make it a tiny bit less ugly and multiply it by 3. We'll sort out our minuses here. So u over g plus u squared over g squared minus 6. Get that nice and tidy. Minus u over g plus, don't forget it, u squared over g squared minus 6. Okay, this is looking a little less horrific because look, we have u over g minus u over g. Goodbye. Now this is getting a bit handier. So what we have is 3 equals 2 square root of u squared over g squared minus 6. And we do have space here. Okay, so what we're going to try and do is do a little bit of a line there. We'll squeeze it in here. We'll get it done. I think we'll fit one more on this bit here. Next step, if we have a look at this closely for a moment, we just have one unknown. Remember, g isn't an unknown, it's a constant. So it's u squared. So this is solvable, it's just a little bit messy. So to make it a little bit less messy, we're going to square it. So we end up with 9 equals 4 factor of u squared over g squared minus 6. All right, we've run out of space at this stage, so we're going to come up to here, multiplying them out. 9 equals 4u squared over g squared minus 24. All right, bring this guy over here. So 4u squared over g squared equals 24 plus 9, which is 33. U squared equals 33 g squared over 4. Right, fun times. So u, of course, equals the square root of all that. 33 g squared all over 4. Out to the calculator. Now we're on the right track here. So I'm just going to do this in 2 steps because I don't want to get too tied up in the calculator. If you're comfortable enough doing it in one, go for it. So what we have here is 33 by 9.8 squared equals that, divided by 4 equals that. Square root of the answer is that, in decimals, equals 28.15 meters per second. All right, and that's a sensible kind of number, fast enough, but that's the kind of number we'd expect to see in it. So there we have it. Dirty bit of algebra, but we get there in the end.